Hi, my name is Jerem Hatch, and I'm an applications engineer for Trilion Quality Systems. Welcome today to this brief overview of some of the many GOM Metrology webinars available on YouTube. Let's go ahead and get started. First up is ARAMIS DIC and Thermography. This webinar focuses on the ability to use different thermography systems in conjunction with ARAMIS DIC. Specifically, a representative from a company called Infratech helps to describe how thermography works and how to combine thermography data with ARAMIS DIC. Mechanical loading on a material, such as with a tensile test, generates local heat sources that can be tracked with thermography systems. ARAMIS has the ability to trigger thermography cameras in order to temporally align data and then import that data and analyze it. You must also spatially align the data in ARAMIS for accurate results. As shown in this webinar, this can be done with tensile testing, but also many other applications, including battery testing and thermal loading. Next, let's briefly discuss ARAMIS for materials testing. ARAMIS can be used for a variety of materials testing, including tensile and compression testing, bulge and Nakajima testing for sheet metal formability, hole expansion testing to determine forming limit curves, edge crack sensitivity testing, 3 or 4 point bending tests, and shear testing. This webinar also discusses the applicable ISO standards for some of these test methods, including 12004, 16630, and 16808. If you're interested in learning more about high-speed testing, this webinar is especially made for you. ARAMIS SRX allows you to capture high-speed data with high resolution. This webinar goes through some of the important aspects to consider when conducting high-speed testing with ARAMIS SRX, such as discussing the ideal size per pixel, placing your test specimen in the center of the measuring volume, how to calculate your needed frame rate, frequency, and shutter time, as well as discussing the proper illumination for your tests. This webinar also included some interesting testing examples, including an automobile door slam test and a head impact test on an automobile windshield. One of the great aspects of ARAMIS is its ability to compare actual data with numerical simulations. GOM provides different systems for use in all aspects of the product development process, including ARAMIS, which are sensors for high precision motion and deformation analysis, ATOS for non-contact 3D scanning, Tritop, a portable 3D coordinate measuring machine system, and Pontos Live, a tracking system for the live positioning of parts typically in production environments. This webinar mainly focuses on ARAMIS and how to correctly import and synchronize numerical simulation data to accurately validate FEA results. This webinar is especially important for sheet metal manufacturing and testing, as it describes the forming limit curve and how to create one in ARAMIS. As a brief summary, the forming limit curve is a material parameter used when discussing thin sheet metal blanks. It is primarily used for formability analysis and material characterization for steel and aluminum suppliers, the automobile industry, and some consumer goods. This webinar describes the testing procedures and how to create that forming limit curve in ARAMIS according to ISO standard 12004. This is a great webinar for learning more about the difference between 2D and 3D digital image correlation. DIC in general is a method of tracking coordinates using variations in grayscale values. 2D measurements are done using a single sensor in conjunction with GOM Snap 2D and GOM Correlate. Only planar specimens can be used, and the sensor must be oriented in the specimen plane for accurate results. Scaling is applied manually, typically by placing a ruler in the image. Specific lenses must also be used in order to capture the effects of lens distortions. 2D DIC can be used for a variety of different applications, including quasi-static and high-speed tests, fracture zone evaluation, 3-point bending, shear tests, and 2D motion analysis. 3D measurements, on the other hand, are done using ARAMIS 3D cameras along with the ARAMIS professional software. Using a stereo camera system, meaning 2 cameras, allows for full field point-based dynamic measurements within a volume. The sensor system can be placed freely anywhere in front of the specimen. 3D DIC is recommended over 2D because it can be used for all the applications mentioned for 2D measurements, in addition to being more flexible and also providing out-of-plane motion analysis. This webinar is an introduction to geometric dimensioning and tolerancing, especially using GOM Inspect. GD&T involves size, form, orientation, and location of parts and features. The typical workflow when following GD&T is creating a CAD model, producing the part, taking measurements of this part, extracting that data in the form of a point cloud, and then comparing that point cloud data to the nominal CAD data. GD&T is dictated by ISO standards 1101 and ASME Y14.5. Going a little more in depth on the different aspects of GD&T, first is the size. Size is set by 5 different parameters: LP, which is a 2-point size; GX, a maximum inscribed element; GG, a Gaussian-based best fit; GN, a minimum circumscribed element; and E, an envelope requirement. Form includes straightness, flatness, roundness, and cylindricity. Orientation includes parallelism, perpendicularity, and angularity. Location includes position, TED pattern, concentricity, and symmetry. There are also 2 other features included called surface profiles, which includes line profiles and surface profiles. CAD files can include GD&T information called product and manufacturing information that can be imported directly along with the CAD model into GOM Inspect. Currently, the supported CAD softwares for using PMI is CATIA versions 5 and 6, NX, and Pro-E Creo. Thank you for taking the time today to watch this brief overview of some of the many and very interesting GOM Metrology webinars available on YouTube. For more information, feel free to visit www.youtube.com/GOM Metrology for any of the recordings, software tutorials, and application examples. Feel free to register for the GOM Surface area, where you can have access to manuals, forums, and our knowledge base. Or contact Trilion Quality Systems directly at info@trilion.com or 215-710-3000.